Okay, we're going to go over simplifying radicals. So a radical is just something that has a root. And though they don't write it in here on this operation, technically there is like a little number 2 here. And what that means is you're trying to find two numbers that multiply to this. Now, let's look at the number 40 right off the bat. Okay, I'm going to quickly go over a couple of values that multiply together and see if we can get to 40, right? So I know that 2 squared is 4, 3 squared is 9, 4 squared is 16. Do you know these off the top of your head if I called you out on it?
Mm-hmm.
What's 5 squared?
5 squared is 25.
How about 6 squared?
36.
Nice. 7 squared?
It is 49.
Ah, great. So 40 falls between here, which means it's like 6 decimal something, okay? But we don't really want to talk about decimal values. We want to simplify it with whole numbers. So instead of taking this root here, if we're looking for exact, it's nice. We want to represent using whole numbers. We're going to go through, we're going to look for multiples or factors of something, okay? So if I have 40, I'm going to think of two multiples of 40. So I know that 40 can be broken into 4 times 10. So I'm going to write this as root 4 and root 10. Okay? In fact...
Oh, I remember how to do it.
Yeah. I can break these into prime numbers. I'm going to break them all into the lowest multiples of every single one. I know that 4 can be broken into
2
root 2
times 5.
Ah, here go your answer here. Great. And 10 can be broken into 2 times 5. Now, the 2's can't get broken down anymore. They're prime numbers. 5, same thing. The only multiples of those are itself and 1. So now what we do is we look for pairs. Because it's the root 2, we go for pairing numbers. And when we pair numbers, we get to get rid of those square roots. So I have a pair here. I have a pair of... Oh, that's a terrible color. Just got rid of everything. Yikes. Let's try blue. Is that better? That's a little better. A pair of 2's. In fact, root 2 times root 2. Okay. Do you know what that's going to be turn into if we get 2 root 2's together? It's okay if you don't. I'm going to do something else. Instead of doing that, I'm going to ask you if you remember your exponent rules. Root 2 can actually be written as half of an exponent. So if I say and a half, that's technically to a half, technically 5 to a half. If we're going to simplify exponents, if I have an exponent times an exponent and the base is the same, do you know what we do with the powers to simplify them?
Cancel them out?
If there's negative and positives, yeah. But in this case, we would actually just add them together. So what is a half and a half together?
1.
1. So this actually becomes, these two become 2 to the power of 1. And 2 to the power of 1 is just, it's just 2.
So does that just become just square 2? Square root 2.
Not just square root 2. It becomes just 2. So I'm going to write this one out to the half and to the half. Okay, I know that I can't really change these, so I'm going to change them back to their roots. Well, 2 to the power of 1 is just the number 2. 2 to the half is actually written as root 2. And 5 to the half is written as root 5. Well, I can't break these down any farther, so I'm actually going to put them back together. What is 2 times 5? Do you know?
10.
10. So it just becomes 2 root 10. Okay? So 40 is actually just 2 root 10. Okay? Here's a much harder question. 441. What a ridiculous value I chose. What goes into it? I'm going to tell you right now, 3 goes into this. Okay? So let's help me out here. 3 divided by 441. Is that something you can do in your head or not quite?
Mm-hmm.
Yeah? 3 goes into 441 how many times? What if you did long division on the side? Want to do it together?
I think I can do it.
Okay. Do it nice and quick. You tell me if you get it. Tell me what you get.
147.
Amazing. That's what I got too. Great. But 147 is also a relatively large number. 3 is a prime number, so we would actually just bring 3 right back down. Nothing else to do with here. 147. We got to break that into multiples too. I'm going to look at it and quickly tell you that 3 also goes into this one. So I can break it into 3 and something. Question is 3 and what? Tell you this one. This one's 49. Okay. So I got 49. Can I break 49 into anything? Multiples of 49. Our writing in blue might help us on this one. I think I found 49 at one point. If you take a look at the right side.
Oh yeah, 7.
7. Okay. In fact, we know that the square root of 49 is 7. So I don't even need to write root 7 and root 7. I can, just to reiterate a discovery way. But remember we talked about this before? If we get a pair together, we can just drop the square root here, okay? So if you take a look, we're going to drop the square root. That's gone. We can just write the number 7. In fact, we have 2 pairs.
So 3 and 7?
Yeah, 3 and 7. They both disappear. So I just have 3 times 7.
21.
Yeah, 21. Let's test that to make sure. 21 times 21. That becomes 21. Now we get a 0. This becomes 2. 4, 4, 4, 1. That's right. It is the square root of it. So we did the exact same process. We actually got a whole answer here. We didn't have to write it in a simplified radical. We can do this prime this prime multiples, and always get an answer when we're doing square roots. Okay? It's a potential way to solve that.